Alright guys, today's goal, the learner will understand equation solving and modeling. Quick review. Prove that each function in the given pair is inverses of each other. Okay? So remember what that means is f of g of x equals x. So if I plug that in, I get e to the natural log e3 to the natural log of x to the 1/3. Then remember we can bring that down. So that's 1, and e to the natural log of x is x. And same thing if you go backwards. So we'll do it this way. So we should go g of f of x equals 10 to the log of x squared divided by 2. We'll bring that down, so 2 divided by 2 is 1, 10 is x. It works both ways. So write the number in scientific notation, 1.234 times 10, 1, 2, 3, 4, 5, 6, 7, 8 to the 8th. Write the number in decimal form, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Because remember, this means move it forward to the left. The positive 8 means move forward to the right. There we go. So what you're learning about: solving exponential equations, solving logarithmic equations, orders of magnitude and logarithmic models, Newton's law of cooling, and logarithmic re-expression. And why the Richter scale, pH, and Newton's law of cooling are among the most important uses of logarithmic exponential functions. So in science it is used very strongly. Okay. For any exponential function, f of x equals b of x. If b to the u equals b to the v, then u equals v. Same thing for log. Okay, we've learned this. One-to-one property. Alright, so solve this. Okay, so first thing I would do, divide by the 40. So I get 1/2 x divided by 2 equals, see, that would be what, 1/8? So we got to somehow get that to match the 1/2, so watch. Well, isn't 8 2 cubed? So it would be 1/2 to the 3rd power, because that's 1/8. Now see how we have the bases using that? You can just say x divided by 2 equals 3, x equals 6. And this was missing equals 27. So think about the same thing here. So we got to think about the same thing here. Divide by the 125. And that's 27 over 125. So that doesn't simplify, but we need it to somehow be 3 and 5. Well, if we think about this, you have 3/5. So think in your head, 3 to what power equals 27 to the 3rd? Is 5 to the 3rd 125? Yeah, so you have 3/5 to the 3rd. So that means x to the 3rd equals 3, so x equals 9. Okay. Now solving logarithmic equations. Okay, it's log base 10 of x to the 3rd. Now, this is what we have to think about here. Don't we know that we can change this to, but doesn't that equal log base 10 of 10 to the 3rd? So see how you have the logs and the exponents matching. So you get x to the third equals 10 to the third. So x equals 10. Because cube root. So there's one way. Another way that we could do this is the ben is equal to the log of benny. So if we did that here, so the base is 10, the base to the exponent equals the number. So ben, base, exponent equals the number, same thing. Cube root, you get x equals 10. Okay. Now, this is what we don't want to do here. We've learned this, couldn't we? Okay, so let's take a look at this one then. So we could say log of x squared equals log of 10 to the 8th. So x squared equals 10 to the 8th. Square root that. So x equals plus or minus $10,000. Okay. So there we go. Make sure you look in the book at example 3 because it's going to show you an incorrect method that you cannot do, okay? Orders of magnitude. The common logarithm of a positive quantity is its order of magnitude. Orders of magnitude can be used to compare like quantities. Kilometers is 3 orders of magnitude longer than a meter. A dollar is 2 orders of a magnitude greater than a penny. See, it's how many times you're multiplying by 10 is the orders. Okay? Here's the Richter scale. Here's the equation you're going to need to use for Richter scale. You might want to copy that down. Copy this down to make sure you know what they all are. A is the amplitude. T is the period. And B accounts for the weakening of seismic waves. pH. The measure of the acidity used in pH is the opposite of common log of a hydrogen ion. This is all chemistry. Newton's law of cooling. So we're going to need to be able to use this as well. So make sure we copy that down. Okay, so here's an example using Newton's law of cooling. Okay. So we want to use the Newton's law of cooling. Okay. Okay, so if we fill in what we know, see how it says 5 minutes later? Okay, so we know T was 5 and it equaled 55, so we have an equation here. 55 equals. Now, the Tm is the water temperature. And then the TO is 100. What's 100 minus 15? 85. E to the negative 5k, because T is 5 minutes. So we have to solve this for the k. So subtract the 15. You get 40 equals 85 e to the negative 5k. Divide by the 85. Do not do a decimal. You need to leave it. So you would, let's see, what would that simplify to? 8/17. So you have 8/17 equals e to the negative 5k. Well, what's the inverse of e? The natural log. So you have the natural log of 8/17 equals negative 5k. Divide by the negative 5. Now is when you can use the calculator and get me a decimal. Give me 3 decimal places. So natural log, make sure you do 8 divided by 17, close the parentheses, divided by negative 5. So you would get k is 0.151. So now that we have k, we can plug in to get when will the egg be 25 degrees Celsius. Okay? So now we're looking at 25 equals 15 plus 85 e to the negative 0.151 t. Subtract the 15, divide by the 85. So 25 minus 15 is 10. 10 divided by 85. Remember, no decimals. 2/17. So you get 2/17 equals e to the negative 0.151 t. Take the natural log of both sides to cancel out the e. Divide by the decimal. The natural log of 2 divided by 17 divided by negative 0.151. It would take approximately 14.17 minutes to cool it down. Okay? So there's a Newton's law of cooling. Yep. Regression models related to logarithmic re-expression. Linear regression is a plus b. Natural log is a plus b times natural log of x. Exponential, a times b to the x. And power regression, a times x to the b. 3 types of logarithmic re-expression. So they're saying this looks like a natural log. You can do the natural log of x times y. And looks pretty good, and it says use a times the natural log of x. Y equals a natural log of x plus b is logarithmic regression model. Okay. Here's the example if you have an exponential. See how this looks like an exponential? And what do? You say x times the natural log of y. We'll go over an example of this in class, but x times the natural log of y. So that means when you have your table, you take your x values and then do the natural log of the y values. And look how it straightens out to a line. And then power regression, you do the natural log of both. Okay? So be ready for class tomorrow, guys.